Hi everyone, I like to just jump right in, so I'm going to start with a story about language. In 1972, Italo Calvino published Invisible Cities, which fictionalizes a series of dialogues between Marco Polo and Kubla Khan, each serving as a contemplation on time, memory, and language. At one point, Polo speaks of his time in Hypatia, a city whose words are unchanged, but whose meanings are distorted. The gardens are places of sadness, the palace is a prison, and the vast libraries are dens of depravity. Reminiscing to the Kogan, Polo has this to say: "There is no language without deceit. Here Calvino speaks not only of the presence of lies, but also of the absence of absolute truth. If a phrase has no essential meaning, then what does it mean, and where does that meaning come from?" I argue that questions like these are fundamental to our understanding of distributed systems, and that by drawing on ideas from postmodernism and post-structuralist thinkers, we can conceptualize a software that's robust in the face of a rapidly changing and diverse world. This is a little bit of a weird topic, though, so I want to anchor it against something more familiar. Imagine a social network. It has over 300 million active users, and for many of them, this site is their connection to the world. And then one day, something happens. Maybe the site crashes and it doesn't come back up. Or maybe the company is acquired and things quickly begin to change for the worst. Huge numbers of people are suddenly thrown into a state of panic as they realize just how fragile their communication channels really are. But then they begin to find their escape, not through another social network, but through a network of social networks, each with no more than a few hundred people each, but all of them able to communicate between themselves. Here, services crashing or reorganizing is not just a daily occurrence, but a feature that offers the network resilience and adaptability in the face of change. In many ways, the work I'm talking about is an extension of this idea. So I want to start by framing things in a similar way. What does the world look like when you have millions of tiny databases? I'm Quinn, and I'm here to talk about postmodern systems, intersubjectivity, and a project my team has been working on, codenamed Dialogue. I'm an applied researcher at Fission, where I've been spending my time experimenting with new ways of building distributed systems. In my free time, I often spend my nights tracing through the history of programming languages, trying to piece together the context that led to their development and how the ideas behind them have morphed and shifted over time. That interest is what's led me to many of the ideas I'll be sharing today. But first, we need to speed run through postmodern philosophy. Postmodern philosophy was introduced by Jean-François Lyotard, who defined it as an incredulity toward meta-narratives. This is only a partial definition, though, and critics often misunderstand what it is that Lyotard is trying to say. To him, postmodernism isn't a period of time following modernism, but instead a response to modernism's tendency to collapse complex, world-spanning events into simple, universal explanations. As Paul Sillars puts it, the postmodern condition is characterized by the coexistence of a multiplicity of heterogeneous discourses. In this way, I prefer to think of postmodernism not as a tool whose imprecision allows you to say anything, but rather as a mode of thinking which recognizes innate complexity and then strives to understand it through a plurality of lenses, whether cultural, geographic, or otherwise. Without doing this work, we privilege the narratives which fit into a framework of precision and formalism, and in doing so, we fail to account for the chaos inherent to the world. I also think that this is something we, as system designers, are especially prone to do, and in a dangerous way. We have a tendency to build clean, simple models of the world, and then we use those models to make decisions which further impact the same world that we're modeling. In A City Is Not a Computer, Shannon Mattern criticizes the use of digital dashboards and the governance of modern cities. Algorithms and interfaces tend to bracket out those messy and disorderly concerns that simply do not compute. When Calvino says that there's no language without deceit, I think this is some of what he means. Even beyond the contextual filters we apply to our communication, the process of deciding what to communicate at all serves to legitimize some discourses over others. And as we see all too commonly in the tech industry, it's only natural that the decisions we make will fail to account for the needs of the people least empowered to articulate them. It's not even that I think these are malicious decisions made by malicious people, but that the entire methodology of top-down design that's pervaded software development since the 70s is fundamentally at risk of building software that models the world using simplifying and totalizing assumptions, often rooted in the experiences of the designers of that software. This ties into a point Sussman made in 1999. Computer science is in deep trouble. Structured design is a failure. This is from a short essay titled Robust Design Through Diversity, where Sussman argues that top-down structured design leads to brittle, inflexible systems that resist modification and fail when their underlying assumptions are inevitably violated. In part, his point is that in designing a system, many plans are proposed, and all but one of these are discarded when the system is finally built. All of this diversity of thought is just erased in favor of a single unified solution that sacrifices robustness and flexibility for false elegance. Later on in the essay, he claims that to advance beyond the existing problems, we must change in a fundamental way the language that we use to describe computational systems. He believes that there's lessons to be taken from biology, and that systems can be composed from autonomous agents, which together evolve according to principles like morphogenesis. It's his use of the word language here that I want to focus on, though. Saussure was a Swiss linguist whose work laid the foundations for what's become known as structuralism, an early model of language that focused on meaning rather than syntax. The central conceit of his model is that language is mediated through synchronous, spoken conversation between participants. Conversation essentially creates a circuit between the participants of a conversation through which the exchange of ideas takes place and consensus around meaning emerges. In his model, signs were composed of two parts, a signified and a signifier. The signifier was some linguistic unit, like a word, which represented a concept called the signified. Saussure's classic example was the use of the word arbor to represent both the word tree and the image of a tree. Importantly, though, while this relation between the signified and the signifier is essential, it's also completely arbitrary, and so the meaning or value of a sign is given by the network of relationships between all signs in a language. Where things get interesting, though, is with the introduction of time. Under Saussure's model, the linguistic value of a sign is essentially immutable, but it can slowly shift in time in response to its use by a community, with the use of speech serving to anchor meaning among the community at any given point in time. There's a problem with this model, though. Much of what we know of Saussure today comes from Course in General Linguistics, a book published by his students after his death out of a reconstruction of his remaining notes and lectures. In the book's preface, two of the students remark on the difficulty of capturing the essence of Saussure's thoughts in written form, given the irregularity of oral language and their inability to clarify intention for Saussure. To me, this speaks of the model's limitation. Saussure had proposed that speech was foundational to language above even writing, and that through conversation, meaning becomes consistent. And yet, not even his students could agree on what he had been saying. And that's where Jacques Derrida comes in. Derrida was among the founders of post-structuralism, a branch of literary theory that grew out of response to structuralists like Saussure. In Of Grammatology, Derrida writes about earlier philosophy's reliance on the metaphysics of presence, essentially the idea that truth is eternal and always at hand. He connected this back to Saussure by inverting the model of language. Rather than prioritizing speech, Derrida focused on writing. His point was that through writing, a distance is introduced between both sides in a conversation, and that this distance serves as both a spatial and a temporal barrier to communication. If language is transmitted forward in time to some indeterminate reader, then there can be no notion of a fixed reference point for the system of language. Instead, language can only be viewed as a localized process, defined by their relationships between signs in a given temporal and spatial context. Derrida's criticism of structuralism reminds me of an argument made by Christopher Meiklejohn in a recent paper titled A Certain Tendency of the Database Community. The main insight comes from the claim that real-world systems are fundamentally eventually consistent. They perpetuate themselves through the exchange of information, in the form of letters, telephone calls, and writing. And so they must be resilient to this information being dropped, delayed, and reordered. To aim for a stronger sense of consistency in distributed systems, then, is to go against this nature. He proposes that rather than targeting global consistency with some primary node, systems should instead be built to treat the local knowledge recorded at each node as being an accurate reflection of the node's view of the world. He argues that to do otherwise is inherently limiting, but claims these designs are common because of the way they simplify the use of existing tooling. Again, we have a case of our technology guiding our world rather than the other way around. He then goes on to briefly acknowledge the incompatibility between the designs he's criticizing and the constraints of peer-to-peer networks and large-scale edge computation. There, rather than one globe-spanning network, we end up with a number of smaller, sometimes overlapping networks, computing over different slices of some total set of data, with no guarantee of ever achieving or even desiring system convergence. The Fediverse starts to approach this idea, where instead of one global social media feed, we instead see localized communities forming, using interconnected software like Mastodon and Pleroma. These communities define their own norms and cultures, and they decide who they're willing to interact with based on shared values and interests. That could be anything from banning Nazis to banning the use of the letter E. Networks like these demonstrate a shift away from centralized top-down control that we've normalized through technology, and toward an internet that actually prioritizes the individual needs of the people using it. But in treating entire communities as the atomic unit under discussion, we still collapse the hugely varied people within those communities into indistinguishable blobs. And addressing this means doing something radical. If this problem arises when a single server is used to provide service for more than one person, then the obvious solution is for every person to have their own server. And at that point, why not do away with servers entirely? Local-first software is a recent paradigm, coined by Ink and Switch in 2019. It defines a set of guiding principles for building software that prioritizes user agency, security, and privacy. The vision of local-first software is of a world that empowers people to take back ownership of their data, freeing it from the tyranny of the cloud and of the centralized services that comprise it. In local-first software, a user's device is the central source of truth for that user, with data all being stored locally and with a hard dependency on the network being severed. Instead, local-first software embraces eventual consistency and makes use of techniques like conflict-free data types to synchronize data between devices. Web Native is a local-first SDK we've been building at Fission. It ties together work we've been doing across a few different domains to support building local-first applications that leverage passwordless authentication with web crypto, WebAuthn, or passkeys. It provides decentralized authorization with our UCAN token format, and end-to-end encrypted storage with a file system we've built on top of IPFS named WinFS. Thanks to Rust and WebAssembly, it also supports all of this in a browser on mobile devices or on a server, all without an internet connection and across multiple devices. To support the kinds of ideas I'm talking about today, though, we need a local-first database too. And so I've been designing Dialog, a decentralized edge database for local-first applications. Dialog takes inspiration from systems like Datomic in order to support eventually consistent views over disparate data structures, like encrypted stores in IPFS. In Dialog, data is persisted as 4 tuples, specifying an entity, an attribute, a value, and any causal links. These causal links denote the provenance of data, and they reference it using a content addressing scheme like you see in IPFS. The resulting structure forms a directed acyclic graph over those tuples, and this diagram here visualizes what that might look like for a small number of writes. Using a query language inspired by Datalog, we can then interpret this structure as a CRDT. In this case, it could be viewed as an observed removed set for a set containing the letters C and D. But because we're using IPFS to derive content IDs, it also guarantees that the CRDTs we build are Byzantine fault tolerant, which means we can support multiple writers and trustless environments. Here, rather than writing data to shared stores, we instead query over the union of potentially many single writer stores. And then due to the convergent nature of CRDTs, this means that different readers can subscribe to different writers, but in a way that guarantees monotonic progress towards some result. This is what enables us to provide every device on the planet with its own database, and allowing those devices to communicate in locally meaningful ways. This is an idea that ends up being especially useful in the context of encrypted data, where certain readers may only have access to certain other writers. In this example, the reader doesn't have the decryption key for the events in gray, and so they're unable to satisfy the causal links for any of their downstream dependencies. And so the resulting set, as they observe it, only contains the letter D. In a sense, we treat encrypted data as a special case of network partition. But rather than some of the data being unreachable due to network failure, it's unreachable as a side effect of not having been granted the required encryption keys. The end result is the same, though, and the partition can be healed by later delegating access to the reader. There's other reasons a reader may prune the resulting data, though, and revocation is a clear example of one. In this case, we can filter out all of the blue events and end up with a CRDT that's consistent with respect to everything else. Importantly, though, this logic is happening entirely at query time, which means that different readers can impose their own constraints on the data. Perhaps I don't trust some other writer, and so I don't want to honor any rights that depend on his. Or perhaps I subscribe to a fact-checking service that annotates news stories with trustworthiness scores that I can use to dynamically filter out non-repeatable stories. Or maybe I subscribe to a feed of crowdsourced content warnings that I can filter and overlay onto the content that I engage with. This goes so far as allowing a total reinterpretation of data too, like here, where the set is instead treated as a counter by viewing additions and removals as increments and decrements. In this way, devices can repurpose pieces of a graph as different types of data, even annotating it with additional fields or metadata for their unique needs. In the case of a collaborative text editor, that might mean prioritizing your own rights over another user's, but while still managing conflicts and allowing them to do the same. As in the case of Derrida's system of language, the meaning of the data is given not only by the relations between it, but also by the context held by each reader. This means that different applications can operate over the same data, extending it for their domain and opening up the possibility of new types of applications. This might include collaborative media libraries that directly integrate private data from disjoint collections, or overlays that empower users to extend and remix existing applications according to their needs. This entirely inverts the way that we build systems like this by prioritizing the user's agency over the sorts of top-down design we're used to. And in all of these cases, the focus is on treating data as a medium onto which users can impart meaning of their own, rather than as a commodity to be walled off and sold. In a world where every device is generating and sharing information, restricting ourselves to a single interpretation of that data is limiting, if not impossible to reconcile with the emergent and complex needs of our users. In the preface to Autopoiesis, Stafford Beer claims that science annihilates real systems, causes relations to be lost, and relegates synthesis to poetry. And I think that that's some of what we see in the way we build systems. If we're to escape that trap, then we need to move away from a single system image view of the world, and instead recognize the inherent complexity of the world we're modeling, and the individual needs of the people our systems are meant to serve, just as thinkers like Lyotard tried to do before us. Partway through Invisible Cities, Marco Polo tells Kubla Khan of a city named Fedora. Fedora is a metropolis centered around a building filled with crystal globes, one for every inhabitant of the city. Within each globe, there exists an idealized version of Fedora, corresponding exactly to the desires of the person who imagined it. Where in one globe, the streets are lined by Venetian canals, and another, elephants parade down those same streets. It's impossible for all of these conflicting versions of Fedora to be real, and so none of them are. But what if Fedora could exist? Not as a monument to all of these cities that can never be, but as the simultaneous realization of their being. Sussman gave us the structure and interpretation of computer programs, but maybe it's with a post-structuralist interpretation of computer programs that we'll be able to bring Fedora to life in the systems that we build and inhabit together. Thank you. I'm Quinn, and I'm looking forward to meeting all of you at the party tonight.
Thank you. Does anyone have any questions for Quinn? That was a fucking brilliant presentation, by the way. Really incredible. Not only was it interesting to learn about all that philosophy and history or whatever, but to be able to understand it well enough to understand the humor involved. Yeah, I was just rolling on the floor about that. The book that everyone uses to learn this guy's philosophy got taped together by his students that may or may not have actually understood what he meant. That's brilliant. What's the name of that philosopher again?
So it's Saussure. Saussure. I'm terrible at saying his name, but the book is Course in General Linguistics.
Okay, which I've seen, you know, everywhere, forever. Okay, great. So any questions for Quinn from the audience?
So can I use dialogue today?
No. The current state of dialogue is basically a series of prototypes that I've built in Elixir. So what I've done essentially is implement a variant of differential data flow in Elixir, and then I've built a variant of Datalog that compiles down to differential data flow that gives you automatically incrementalized views over data. So all of the ideas work. I have demos that show them off, but it's all prototype code right now. So I'm in the process of writing a specification for the rest of my team, and we're doing a Rust implementation that'll run over the rest of the web native stack that I briefly alluded to. Web native exists though, and there's like Google Apps clones, a Google Drive clone, decentralized music players and stuff built with it. All of that's totally usable.
Cool. All right, here we go.
So I can't help looking at entity, attribute value, causality, I can't help but think that's also RDF, right? Quads? Exactly.
Sorry, you were a little quiet. Did you ask, is the causality the same as RDF?
That model of the four items, does that not map directly onto RDF? The causality being the quad, the fourth term.
Mm-hmm. There's definitely a lot of overlap, and a lot of inspiration has been taken from RDF. I'm hesitant to say that it maps exactly to it, though, because we are not, we're not targeting everything else that lives alongside the RDF ecosystem, and we're more trying to find like a synthesis of what we like from systems like Daedalus or Datomic and RDF and so on. So we don't want to kind of box ourselves into a corner by calling it RDF at this point.
Okay, great. All right. Any other questions? All right. Thank you very much.
Yeah. Thanks for having me.